Hi, so welcome to part 2 of our lesson on scenarios and chapter 3 concepts, scenarios and graphs, etc. We're going to extend this a little bit now, and so here's the same example that we looked at before, and the equation that we're given, same sort of thing. We've got the table of values, etc. One thing we're going to look at now is I'm going to look at what information we can get from the table of values and how that links to the graph. So one thing that I'm going to look at is we know that this is, of course, the independent variable, the x, and in our example, we used n for the number of guests. We used C instead of Y for the total cost, and that's the dependent variable because that depends on the number of guests that arrive. And so what I did with the independent variable is I decided to go up in terms of 5. So each different scenario, I chose 5 guests higher than the last scenario. Okay. So notice that every increase there from one row to the next in the table is 5. If I look at the increase or the change, I guess it's more specifically a change, but it is an increase in this instance, the change in the total cost from one row to the next, I see that that's 100. So I could look at it and say, okay, well, I go from 250 to 350, that's a difference of 100. If I go from 350 to 450, that's a difference of 100. 450 to 550, that's a jump of 100. And 550 to 650, also a difference of 100, etc. Okay, so same thing all the way along. Notice that all of these values, these differences, and actually I was saying jump and I was saying difference. This column of hundreds that I just wrote, those are actually in a separate column, and those are called first differences. So once I find the first differences and put them in this table is now called a difference table. Okay, so now I can look at it as a difference table. And if we think back to the words of, or the terminology of addition, subtraction, multiplication, and division, remember that addition, the answer to an addition question is a sum. The answer to a subtraction question is a difference. The answer to a multiplication question is a product. And of course, the answer to a division question is a quotient. Okay, so this is a difference table because what we're actually looking at is we're looking at the differences between consecutive values. Okay, so the difference between 250 to 350 is 100. So if we were to subtract, if we subtract up, we say 350 minus 250 is 100. 450 minus 350 is 100. 550 minus 450 is 100. So if I'm subtracting up each time, I'm getting a difference of 100. And notice that all of these differences are constant. Okay, those are constant differences. Okay, meaning that each row has the same difference as the row above. Okay, which tends to tell us that the growth or the increase or the change in total cost is going to be the same for every jump in 5 guests that arrive. And we can do the same thing on the left side too. We don't really talk about it in differences on the left side for the independent variable, but we do still do this because there is a reason for this. 5 minus 0, so I'm going to count or subtract up. 10 minus 5 is 5, 15 minus 10 is 5, 20 minus 15 is 5, and 25 minus 5 is, or 20 is 5. So again, these are all constant as well. Okay, so this is important that if the differences in the dependent variable are constant, it's important that the differences in the independent variable are constant. Okay. If they're not, if the differences in the independent variable are not constant, then what I'm going to show you won't really work out as well as it should, or it won't indicate the same thing. So I'm saying for every increase in 5 guests, the total cost for Sam is going to be $100. Okay, and that's what this is telling us right here. So this is actually what we're doing here is actually we're determining the rate of change of cost. Okay, it's a rate. So rates will compare different things. Okay, so rates are comparisons. So a rate of speed, so the rate of that we call speed, speed is actually the rate of distance, or the rate of the change of distance. I'll use this little delta symbol. That delta is a scientific sort of term, which means change in. And so speed is the rate of change of distance over the change in time. Okay, so it's a rate because we're comparing. So here we see is a comparison. We're comparing the change in distance over the change of time. So that's a rate. So speed is a rate. Okay, you can have a rate of pay as well. Rate of pay would be maybe dollars per hour. That's your rate of pay, which we call wages or a wage. And so here we're talking about the rate of change of cost. And the rate of change of cost, in this case for this scenario, is the change in cost, divided by the change in number of guests. Okay, so if we were to look at that, and I'm just going to make that I a little bit better. There, change in cost. Okay, so we see that for every 5 people that get increased, the total cost changes by $100. So the change in cost is 100, and that's where we have this first difference. And the change of guests here is 5. Okay, and so 100 for every, so this is telling us for every 5 guests, the total cost, actually maybe I should change it, say the total cost here. For every 5 guests, the total cost is going to be increasing by $100. And then now we can actually simplify that because 5 divides evenly into 100, and that equals $20 per guest. Now, where do we see the $20 per guest before? Aha! Up here in $20 per plate. So this is telling us the rate of change of the total cost. Okay, the 250 is a fixed fee because that's going to happen when there are 0 guests taken into account. So that's fixed. In the last video, we saw that every time we calculated a different row, we started by adding we had the 250 first, and then we added on 5 times 20, and then 10 times 20, and then 15 times 20. But we kept that 250 first because that's a fixed cost. That's the cost that won't change. That's the reservation fee that Sam has to pay just to reserve the banquet hall. But the $20, well, that is part of the variable fee because we know that n, the number of guests, is the variable, That comes from the word to vary, which means to change. Which means, of course, that as we look down at the different rows in this column, in this table of values, the value of n is changing. So for each different scenario, we look at when there are 5 guests, what the cost is, what's the cost when there are 10 guests, what's the cost when there are 15 guests, etc. So the value of n is changing, is varying. That's why it's a variable. Okay. And of course, we know that there's another variable up here, that's the c, and of course the total cost is changing as well as the n changes. We know, of course, that the c, the cost, is the dependent, and so the total cost is depending on the change of the number of guests, the variable n. So we notice that 20 is part of the variable term, or the variable fee, and the number of guests will make that total cost change because the variable term, or the variable fee, will keep changing depending on the value of n. And notice, of course, as well, that 20 that we just looked at up here, without the $sign, the 20 corresponds with the 20 in the equation, which is the coefficient of the variable. So we're looking at a couple very important things here, as I can spell this, coefficient. When we have the variable term, we have a coefficient and a variable. The coefficient of that variable is the rate of change. Okay, so this coefficient, I'll use blue here. So this coefficient of this variable is the same as the rate of change. And then the variable will, of course, dictate the values, or the value of the variable, sorry, will dictate the total value of that variable term. Okay, so all that information kind of blends together in perfect harmony and unison. I'm going to stop here, but I will now, in the next video, I'm going to connect all of this to the graph. Okay, thank you for your attention, and we'll see you in the next video.